So this session is going to demonstrate some of the other relational algebra operations that are available. Last week we covered projection, which uses the pi symbol. So pi symbol basically allows us to choose particular columns from a relation or a table. This is a quick recap of what we did last week. Just imagine you've got this problem here which asks us to find the salaries for all staff, and it's quite explicit here because it tells us which columns we're actually interested in. So you can see it says the nth number, e-name, job and salary columns. So we want all the values in those four columns. So the way that we would lay that out is step one, write down the name of the table, which is the nth table, put that in brackets, and outside the brackets in subscript in tiny little letters we write down the names of the columns that we actually want to show in our output set. Obviously that corresponds to nth number, e-name, job and sal. And then at the front we put the operation, and in this instance the operation is projection. Projection will give us the values in all the columns. Now the equivalent expression in SQL, so if we want to do a projection in SQL we have to use the reserved words select and from. So again, first step, identify the column, and the column in this, the table in this instance is the nth table. That goes after the reserved word from. And then on the top line we have the reserved word select, and after that we list the columns. So we've got nth number, e-name, job and sal. So you can see there's a quite clear correlation between the way that the operation is implemented in SQL and what's actually going on behind the scenes. The projection operation is actually giving us those columns from the table. And if we run that SQL statement, which behind the scenes does the projection for us, we would get this as our output set. So you can see that we've got all the values in all four columns. So projection gives us particular columns that we're interested in. And watch out for the little trap. Sometimes students get a little bit confused because in SQL we use the word select even though we're going to do a projection, so watch out for that. Well, the next thing to look at is selection. And selection is going to use a small sigma operation, and what it does is basically it gives us particular rows. So projection gives us particular columns, selection gives us particular rows. Now, the way that we actually write that down in relational algebra is we use a small sigma and then a predicate, and inside the brackets we write down the name of the table, or tables that we're going to use. Most of the examples you'll see at the start of this will all involve one table. It's easier to actually explain this using an example, so let's plunge right in. This example says list all staff with a salary greater than 25,000. So as you can see, what we're specifically interested in here are those rows where, if you have a look at the salary column, you can see the salary is greater than 25,000. So we're only interested in those rows that are white here. So it's very clear that this is a question, a query which is asking us to give particular rows back rather than particular columns, just rows that match that particular condition, that particular evaluation that we have to have that occurs over each of the rows in this table. So to write that down in relational algebra, it's the same kind of process that we saw when we did the projection example. First thing you need to do is write down the name of the relation inside brackets, the name of the table if you like, and in this instance it's the nth table that we're actually working on. That goes inside brackets. In front of that, rather than write down the names of the columns, as we did with the projection example, we need to write down a condition, or mathematically we call that a predicate. Again, you'll write it in tiny little letters, subscript. We've got, there it is in green. Now the way that we express a predicate in SQL, it's very similar to many other programming languages. We can use, it's typically things that look something equals something, or something is greater than something, or something is less than something. It's an expression that will be evaluated, and when it's evaluated it will return a value of true or false, and if it returns true that means we will include that row in our output. And there's a particular syntax that you can see. It's always name of a column and then an operator and then some particular value that you're looking for or comparing against. So here are some examples. We can see job equals manager. And what we're doing there is we're testing each value in the job column to see if it actually corresponds to this particular set of characters. The set of characters here is the word manager. Sal greater than 30,000. So is the salary greater than 30,000? You can build more complicated predicates by using special reserve words and, or, and there's the reserve word not. So let's say that we wanted to find all the people who were administrators who earned over 25,000. Then we could go job equals admin and salary greater than 25,000. Now, one of the things to watch out for here is that when we're using numbers, you can just write the numbers down. So as you can see in the middle, where it says salary greater than or equal to 25,000, we don't have to do anything special about the number. We can just explicitly write the number down. We've got com is less than or equal to 300. And then there's this one at the end, which is if we want to express not equal to, then we can use a less than and a greater than sign, like that placed together. So that one in the middle reads department number is not equal to 3. If we are dealing with a number, we just write it down as it is. But if it's a comparison against a string, then we must always remember to wrap the string up in double quotes. And in the final row, you can see that you can build more complicated expressions using and or not. So that example says find all the people whose salary is less than 25,000 and who works in department number 5. And you can make these conditions as long as you like, just adding more and more parts separated with ands, ors and nots. So let's go back to the example then. Our example says list all staff who have a salary greater than 25,000. Now in this instance, we know it's the emp table, so our predicate is going to have to describe a situation where we only want to include people whose salary is greater than 25,000. And that's how we do that there. Now the important point to note here is of course that you must use the name of the column. And the name of the column is sal, not salary. If you use salary, the database wouldn't know what column you're actually referring to. So we have to be quite precise about the names of the columns. Now if we could evaluate that against the database, the set that would be returned back, the relation that would be returned back, would be these columns. So you can see it's only the people whose salary is greater than 25,000. So let's have a look at another example then. Show all the staff who are managers. So step 1, identify the name of the relation, the name of the table that we're actually working on. Well, it's the emp table again. Now we need to work out what our condition would be, and in this instance it's going to be something that's going to involve the column job, and we need to go only show me people whose job is the string manager, and it's words, it's a string, so we need to wrap it up in double quotes. And when we evaluate that, we get back this relation here. You can see if you look in the job column, it's only returning those 3 people because those are the only 3 people whose job matches the word manager. Okay, another example then. Show all the staff who are managed by employee number 734. So we start off by identifying the particular relation that we're working on here, and that's the emp relation, so emp goes in the brackets. The condition will be a condition on a test on the manager column, and in this instance we're testing a number column. So we go manager equals 734, we don't need to put any quotes around that because it's a number, and here you can see all the people who are managed by employee number 734. So if you look in the manager column, clearly it's 734 all the way down. Display all the staff who are administrators and earn over 22,000. Step 1, work out what the name of the table, the name of the relation is that we're actually working on. Well, it's the emp table again. And only show staff who are administrators and earn over 22,000. So this is a little bit more complicated because there are 2 tests that need to be performed. We're only interested in people whose job equals admin. Now, admin is a label, it's a string, so we do need to wrap that up in double quotes. The other test is that we want people whose salary is over 22,000. And we want both of those parts to be true, so we place an and between them. And in fact, we only get one person back from the relation. It's Mr. and Mrs. Black. And if you have a look, you can see, this is, if you look under the job column, you can see that they've got admin as their job role, and their salary is 23,000. So you can see that both parts of the subcondition are satisfied. So that's how we evaluate selection and how we implement selection in relational algebra. And that's what's going on behind the scenes in a database or in our theoretical relational model. How do we do it in SQL? Well, as I've discussed, we can get 99% of the way with most of our SQL statements just by using 3 reserved words: select, from, and where. Well, to do selection in SQL, we will need the where part today. So let's do those examples again. List all staff with a salary greater than 25,000. So step 1 is, like we did before, to work out the name of the table that we're actually interested in, and that goes after the reserved word from. Now in this instance, there is the table that we're actually working on will be the emp table. So what you have to do is you have to look at the query, you have to look at the question, and think about what particular columns am I interested in, am I going to be working on, how are those going to be included in my output set. This query involves the salary, and we know that that's inside the emp table, so we go from emp. Step 2, write down the particular columns that we require. Now if we want all the columns, then we could use the star, or we can actually write down particular columns. Now this question just says show all staff. It doesn't explicitly list any particular columns that we're interested in, so I'm going to use the star here to show me everything. Finally, down the bottom here is the where clause, and this is the bit where we're going to actually add the condition, add the predicate. So in this instance, we want to show people whose salary is greater than 25,000. It's the same format, the same syntax as in relational algebra. Sal is greater than 25,000. And you can actually type that in, run it against the table, and this is the result set that you'll get back. Behind the scenes, when you actually type this into SQL and you press run, what's actually happening is that the database is converting it into projection, selection, Cartesian product, all those other operations that are in the relational algebra table, and then it's running them against the database. So here are a couple of examples for you to try and translate into SQL, and if you've got access or database to hand, then you can actually try running the SQL against the database table. So find all the people who are managers, find the people whose manager code is 734, and find all the people who are administrators and who earn more than 22,000. So I'll leave that as an exercise for you to try and translate those into SQL. Now, more complex queries, of course, require not just selection or projection on their own, but in fact they require both. And the elegance of SQL is that these 3 reserved words very clearly allow us to describe a selection and a projection. So let's progress with an actual example. What we'll do is when we want particular things to be selected, we'll place them after the where clause. And of course at the top, when we want a projection to occur, we just place them after the select reserve word. So we can do both. So here is an example of something that's more complicated, something that's going to require us to do both. Produce a list of staff who earn over 25,000, showing only emp number, e-name and job. If you ever think about that, you should realise that actually it's not just asking us for particular rows or asking us for particular columns, it's actually asking us for particular rows and particular columns. And you can see there are the particular rows that we're going to be interested in. So those are the people who earn over 25,000. But of course it's actually asking us only to show emp number, e-name and job. So in fact it's just those three columns and it's only those values in white that we're actually seeking at the end. So go through the steps. Step 1, work out what the particular table is that we want to perform the query or the SQL query against. It's the emp table. So we just write emp down there after the reserve word from. The particular columns that we're interested in, well, we know that's emp number, e-name and job. So I'm not going to use the star this time. I'm just going to actually write down emp number, e-name and job. And if you remember, we separate those columns with a comma. Finally, down next to the where clause, the where statement, we can write down the actual expression, the condition that's required here. And in this instance, we're interested in people who earn over 25,000. So you can see very, very clearly that we've got a projection and a selection, particular rows and particular columns. And if we run that against the database, we just get back the particular columns and the particular rows that we're interested in. Now, one of the things to watch out for here, if you've ever done any programming before, then you might think, well, wait a minute, we're doing a test on the salary column. Do I need to include that when I actually do the output? If you think of terms of input, process, output, if you've done a previous computing course. Well, no. The nice thing about SQL is that you can use whichever columns you like inside the query, and there doesn't have to be a correlation between the columns that you're actually testing against and the ones that you actually display. So you can see that I don't have to include the salary column in the select clause. SQL will do that for you. It will run an evaluation, complex evaluation tree inside the database. It will only find the values where the salary is greater than 25,000 and only show you the particular columns that you want to be displayed. That will just work. You don't have to worry about it. Now, there are loads of other exercises for you in the lab exercise involving both projection, selection, and in fact, there's a little bit in there about ordering as well. So that's what you need to work on in the lab.